So good morning. Today's topic, class 10th mathematics, polynomials. So what is polynomial? So the name itself has meaning. Poly means many, nomials means terms. Polynomials means many terms. And a polynomial is an expression made with constants, variables and exponents, which are combined using additions, subtractions and multiplications but not divisions, right? And we can define in another manner, a polynomial is a non-negative power of a variable, is nothing but a polynomial. And here what I said, polynomials means many terms, right? Then how to identify the terms? The terms are always differentiated by either plus or minus, means how many number of terms are having in a given polynomial. And so we have some types of polynomials based on terms, based on degree. So based on terms, we have some types of polynomials, that is monomial, binomial, trinomial, so on, multinomials. And here, before going to discuss about polynomials, we need to understand all these concepts. Polynomials, so monomial, so an expression or a polynomial with one term, it is called monomial. With two terms, binomial. A polynomial with three terms, that is trinomial. More than three terms, simply we called as multinomial, or simply we called as polynomial. So, and apart from that, we need to understand about coefficient and leading coefficient. We have two types of coefficients. One is constant coefficient, another one is variable coefficient, right? And here we have some terminology about polynomials. First one is a term. A term is a number or a product of number and variables. Here we have some examples: 3, 5x square minus 2x. And just now I said coefficient is a numerical factor of each of the term. So 5x square, in 5x square, 5 is the coefficient of x square, minus 2 is the coefficient of x, 9 is the coefficient of x square into y, right? A constant is a fixed value, it does not change at any cost, means generally all the numerals can be taken as constants. Whereas variable means it can change. The name itself has meaning, it can vary. So it can change, depends upon the situations. For example, if you take 3x, 3 has fixed, whereas x, instead of x if you have taken 1, the result will be 3. Instead of x if you have taken 2, the result will be 6. So similarly, variable means it can change, depends upon the situations. Generally all the alphabet can be taken as variables. Now coming to polynomial, a finite sum of terms of the form a into x power n is the general form or standard form of a polynomial. The power should be positive. Please try to remember, the power should be positive, means non-negative. If it is negative power, it is not a polynomial, right? Where a is a whole number. And just now a standard form of a polynomial means x power 6 plus 4x cube plus 3x square minus 7. So we can create n number of examples about polynomials. Next, before going to discuss basic concepts with examples, so we need to understand about 0 of the polynomial and value of the polynomial. So 0 of the polynomial, value of the polynomial means if p of x is a polynomial and k is some real number, p of k equal to 0, then k is called 0 of the polynomial of p of x, means which value is going to satisfy of the given polynomial, means the result will become 0, then the value is called 0 of the polynomial of given polynomial. Value of the polynomial means we have to get the result as some value. For example, p of x equal to x plus 1. Instead of x if you have taken minus 1, then the result will be 0. So minus 1 is called 0 of the polynomial of p of x equal to x plus 1. Whereas instead of x if you have taken 1, so p of x equal to 1 plus 1, that is 2, where 2 is called value of the polynomial of p of x equal to x plus 1, right? Next, Here we have some graphical representation of polynomials. So graphical representation of polynomial means we can represent in terms of linear as well as quadratic. So linear means the power of a variable is 1. So before going to discuss the graphical representation, we need to understand about the degree of the polynomial. The degree of the polynomial is nothing but the highest power of a variable. The highest power of a variable. The highest power of a variable means the highest power is 1, that is linear. Highest power is 2, that is quadratic. And highest power is 3, that is cubic. So more than 3, 4, 5 simply we called as, if the highest power is 10, that is 10th order polynomial. Based on the powers, here we have some graphs. For linear polynomial, we will get one type of graph. For quadratic, we are getting parabolic path, like parabolic path, U-shape graph. And the cubic means some curved path. Means if the line touches the x-axis at one point, it has one solutions, like the second one, see second one. And here also see the line touches at 1, 2, 3 points, it has two solutions. And fourth one, the curve touches at 2 points, it has two solutions. This 1, 2, 3, 4 points, it has 4 solutions. See, the line or graph or curve which touches the x-axis at how many points, then it has that many number of solutions. So each and every graph is purely based on degree of the polynomial. Degree of the polynomial is nothing but order of the polynomial, right? Then here the relationship between zeros and coefficients, it's very important. So how can we relate of the zeros and coefficients? Here ax square plus bx plus c is a quadratic polynomial. If it is having alpha and beta are the solutions, then the sum of the zeros or sum of the roots alpha plus beta equals to minus b by a. It is a formula, minus x coefficient by x square coefficient. Similarly, product of zeros alpha beta c by a, that is alpha beta, that is constant term by coefficient of x square. See, if the quadratic polynomial is given, we can find out the zeros by using factorization method. When the zeros are given, how to find out the quadratic polynomial? By using this formula. Here p of x equal to k into x square minus alpha plus beta into x plus alpha beta. This is the formula to find a quadratic polynomial when the examiner may give the zeros. Okay, right. So here we have some examples about how to find out the zeros and coefficients, how to relate the zeros and coefficients of a given polynomial. So here we have a small example, 3x square minus 2. If you simplify x equal to plus or minus root 2 by 3, means one value is alpha, another value is beta. Then make sum of the zeros and product of the zeros. So we will get the result. Similarly, we have another method. We use the formula minus b by a, c by a. So we have two methods to find roots and take sum of the zeros and product of the zeros, or else you can take minus b by a, c by a by using formulas. And after that, remainder theorem. So remainder theorem is nothing but, in the earlier case, dividend equals to divisor into quotient plus remainder, right? But how to represent in terms of polynomials? That is, if p of x equal to g of x into q of x plus r of x, that is called division algorithm. Here we have division algorithm. If f of x, or else we can represent it as p of x, right? Notation is our wish. Or any two polynomials with g of x not equal to 0, here f of x equal to g of x into q of x plus r of x, where r of x equal to 0. So here r of x equal to 0 or degree of r of x less than degree of g of x. These are the conditions for division algorithm. See, whenever you may take long divisions, we need to follow these two parameters. These very, very important conditions while you are doing long division method, right? So it's nothing but remainder theorem. And division algorithm means, let's say here we have some theoretical part. If you read, you can understand. So what are the division algorithm consisting of? See, f of x, g of x, q of x, r of x. R of x remainder, q of x quotient, g of x divisor. Either f of x or p of x is nothing but dividend. Okay. So here we can find out quotient and remainder by using long division method, right? So here we have a small example for long division method. So 3x square plus x minus 1 is a dividend, where x plus 1 is the divisor. So here we are applying long division method. The remainder is 1 and the quotient is 3x minus 2. And also we can take some of the examples like, so we can find out any number of zeros. Sometimes he may ask 4 zeros or 3 zeros or 2 zeros. So we can use long division method. We can easily find out the solutions of a given polynomial. Similarly, we have some more examples. Then how to find out when 2 zeros are given, then the rest of the 2 zeros. So by taking the 2 zeros at the product of those two, then we get one quadratic form. Then if you go for long division method, then you will get some quotient. So if you take the quotient as a factoration, so you will get 2 more zeros. So in this way we can find out 4 zeros of a 4th order polynomial. Yes, so this is the way we can find out n number of quotients. Then we can create n number of quotients in polynomials. Then we can find as well as the solutions of a or the zeros or the roots of a given polynomial by using long division method. So please try to remember dividend equals to divisor into quotient plus remainder. And here we have one more example. Sometimes we miss some terms like, see, if we see the divisor x cube plus 2x square plus a, and this is the dividend x power 5 to last b. So if you follow the long division process, so finally I got some value. So in the question he has to get the remainder should be 0. When the remainder should be 0, then we have to equate this value equal to 0. Then we can find out the value of a and b. So sometimes we may not have in our textbook, but these type of questions we can see in a R.D. Sharma textbook. So why? Because most of the times in the board exams, the examiner may give from R.D. Sharma textbook. So please try to go through these models. Then you can easily understand how to find out quotient and remainder of a given expressions or polynomials. And apart from that, we can find the missing terms of a divisor and dividend. Okay, thank you.